Okay, guys, so let's start for the today's session. I think people who were interested in joining has already joined. If people will keep on joining, they can come. And if they have missed something, probably we will cover it time. Just provide them a brief overview. So the main purpose of today's session is to explore how mobile and IoT theft prevention using blockchain. But in order to start exploring the solution, firstly, I will take a brief overview about blockchain, what blockchain is. It will be kind of a brief session which I was supposed to take the very first session, but I couldn't. The slides which I have shared around that, I have condensed that slide and we will go through introduction, a very generic introduction around blockchain, so that the people who do not understand blockchain, people who do not know blockchain, can follow up with what are the issues we are going to solve in mobile and IoT theft prevention. The very first session today will be more focused on the problem. What kind of problem are there? And what are the current legacy solutions around it? How people are trying to solve that problem or how that problem is getting solved currently? What are the lacunas in it? What are the core issues in it? And we will explore these all things. I will let you brainstorm for a few days around it, given you will have an introduction around blockchain, what blockchain is all about. You will be required to apply those blockchain concepts around those core issues and core problem. And all the people who are part of this particular cohort will be recommended to submit one small write-up around it. And then in the next session, if people have submitted the write-up, they will be discussing, I will be providing the floor to them at the end of the session to discuss their solution, to talk about their solution, why they feel that that solution is the one which will solve the problem. And as well as I will delve more into the blockchain solutioning aspect, how those core lacunas can be solved using blockchain code concept and blockchain code functionalities. So let's start the session for today. So blockchain in general, what it is, it's basically a database, basically a ledger, which records transaction, which records information in a chronological order. The speciality of this database is that it is an append only. It means you cannot go back in time, manipulate the ledger. You cannot go back in time, manipulate the information. Whatever goes is an append only. So this particular chronological chain which gets formed, or the chronological order which gets formed, has a special construct in which those formation happens. So first those information or transaction are clubbed. That clubbing is called block, and then they are chained. Then chaining happens, so that is why a blockchain. So block refers to a set of transactions that are bundled together and added to the chain at the same time. One of the very early imprints of blockchain was Bitcoin. Bitcoin was built more as a financial instrument, more as a financial ledger in which you can transfer value to somebody. Underlying value was given nomenclature as Bitcoin. We will not dwell very much into what cryptocurrency and all is that, but just consider it as a transfer of value, which happens and which used to get recorded in ledger. Why they wanted to use technology as blockchain? Because since there was no central regulation, they wanted to run it without any central authority. They wanted to run it without any central regulation. They wanted to run via community. They wanted it to be community driven. They wanted to have a system which is trustless, which is transparent, at the same time has certain aspects of privacy. Another important very aspect is how these block formation happens and around how these transactions are clubbed is something known as cryptographic hash. So hash are a special type of mathematical function. For a layman, you can understand them as something as a black box in which if you give an input, you get an output, but you cannot deconstruct the input from the output again. And it is probabilistic improbable to get a similar output for two different input. So every input leads to a different output. From output, you cannot recover the input statement or the input entry value which has been provided. The very first block in the blockchain is called Genesis block. Trying to more deconstruct blockchain definitions into constructions which can be more understood. So each of these blocks which is written, consider them as certain construct. So a technology. So blockchain is a technology. It permits transaction to be gathered into block and recorded. So this is one part. It means transactions are gathered, recorded into or put into block and recorded. Other construct, cryptographically chain blocks in chronological order. So technology aspect of cryptography comes into picture. It means blocks are arranged in a chronological order using cryptographical methods, allowing resulting ledger to be accessed by different servers. What it effectively means, whatever these information is, it is distributed in nature. Anybody in the world can have access to it. When I say this particular statement, it changes certain flavors as we go deep dive into the blockchain world. But currently at a generic level, consider there are construct which allows in blockchain where the resulting ledger or the information or the data can be accessed by n number of server or any different server around it. What potential it has? One of the very important potential is it disintermediate markets. So disintermediate markets has various meaning. It has various connotation. It has various intent. But at the very core, what it means that it is removing the part where a centralized regulatory body is required. It is removing external parties which bring in trust to the various stakeholders. So let's say in an insurance industry or in a banking industry, or let's say a very simple example is in a trading industry where you go and you trade stocks. You do not directly trade stocks on exchange. It is always via broker. So that broker is an intermediary. Why it happens? Because there are certain risks involved. There are certain financial risk involved on both sides of the party, whether somebody is selling, whether somebody is buying. Exchange is just a marketplace which has certain construct to mitigate the risk. But broker comes into the picture, who brings in the trust, then depository parties come into picture who act as the depository party, who make sure that your stocks are stored in dematerialized forms with them, act as them again as a trust holder, act again as a third party. So the overall is when you start maintaining data in the form, as I just now explained, in form of ledger, which is append only, which can be accessed across the world from a number of servers. It is chained in a cryptographical order via cryptographic hashes. So it brings in that amount of trust automatically. Securing information, same intent, cryptography hashing, making sure it is append only. You cannot go and change the information. You cannot, if you change the whole, everybody knows because the same information is redundantly stored in all the server across the world. So changing information in one server doesn't actually changes the information. Other aspect is bridging data silos. Now, this has to be looked at from, this can be looked at from enterprise aspect, from enterprise lens, where there are a number of departments who have their different databases, who have their different information stored separately, where information are accessed on demand basis via FTP, via file dump, but you never have a real-time access to those information. It can be looked from the lens of two business communicating with each other, two business trying to interact with each other. Both businesses are having technology deployed on different stacks. Both businesses are trying to use database in different formulation, having different architecture or different way of interaction. So there is no direct access to the information. The only direct access is either by bringing in a third party or by getting what by demanding from them. So I will take a pause for a few minutes here. If anybody has question around what we have discussed up till now, around very basics of blockchain, let me know. Feel free to type in question in the chat box or feel free to take up the mic and ask the question.
Probably a question towards end of the session, maybe Ajay. I think I would be interested in knowing what is layer one blockchain.
Okay, sure. I will cover that at the end of the session. Or
Sure.
probably if it comes around our talks in between, I will cover it.
Perfect. Thank you.
So this is the semantic representation, what I have been talking about, how blocks are chronologically in a cryptographic manner ordered, linked. So in general, you will see a lot of technical terminologies here in this particular page. For time being, you can just assume these sections as it is. We will not require to go deep into it. It's just a representation so that I can show that how those chronology order happens. So this block 0 is nothing but the Genesis block, right? It has something which is called version. It has something which is called Merkle rule hash. It will have a timestamp. It will have nonce associated to it. Probably in some advanced session, we will cover what the Merkle rule hash is, what the nonce is. If these are important terminologies around formation of block, around incentive mechanism, how the incentives are rolled out in blockchain. So this Genesis block gets formed. There are two distinct sections in every block. One is called header. Header contains version, previous block, header hash, Merkle root hash, time, and bits nonce. And then the other block, which is called transaction. So transaction is what I am talking about, where you group all the transaction together, bunch them together. So that particular part is this. Now, when the next block formation happens, it is linked to the previous block, where this previous, if you see, the header had one thing which is known as previous block header hash. So they take whatever this particular block is, they take the hash, they put it inside here. They also put in Merkle rule hash. Similarly, the second block is formed. So let's say if somebody comes and starts changing into its local copy, and everybody is going to have these three blocks. Let's say at this point of time, the blockchain only has these three blocks. So everybody in the world who is running this particular blockchain server will have these three blocks locally stored to them. Let's say one of them is a malicious actor and want to change. So he goes on to this particular block one data. He puts in, instead of TX1, he puts in some other transaction which may be beneficial to him. What it actually does, it transforms the hash, cryptographic hash of this particular whole block once. So the way it was earlier linked, in block 2, it is not linked. Now, in order to change it, he will require to go and change each of these blocks in the sequential order in its local copy. Plus, since across the world, everybody is having a different version, and the majority rule persists in blockchain worlds. Whatever is considered right is something which is stored by the majority. So firstly, he not only need to change all the thing on his local copy, he will require everybody in the world to accept that his local copy is correct. And there are certain incentive mechanism in place. There are certain reward system in place, which rewards for honesty. So that particular behavioral economics brings in certain tenets in which this particular type of malicious intent, this particular type of manipulation of data gets discouraged. So as of now, we can skip this block. I will take this particular block in a more advanced section, but just a representation of previous one and having a how Merkle tree, or the how Merkle root actually look like and how Merkle tree formation happens. We'll take this particular aspects into more advanced session. So in the journey of blockchain, which started with Bitcoin, as I already told you, right? So when the Bitcoin started as a blockchain, it was mainly just a ledger which stores information, which has certain financial information, which has certain transactional information. Apart from that, Bitcoin was serving no other purpose. So people started to look into the technology aspect. Can there be something more to it? Can there be something more better way how applications are built? Can we use this technology in that particular aspect? Because there were the technology aspects around trust, transparency were already ingrained in the very first Bitcoin as a blockchain which was formed. So people started to think how to add certain programmable features into blockchain, how to add a piece of code which also becomes transparent, which also becomes distributed, which also becomes decentralized, and where nobody can go and randomly change that particular piece of code without notifying everybody, without taking approvals from all the parties which are involved. So that is how a smart contract got formed. This particular smart contract formation then lead to a lot of innovation which you are seeing currently in blockchain space, whether it's DAO, whether it's DeFi. All of these stems from the fact that now blockchain has an decentralized, distributed, programmable piece added into its core tenant. So defining a smart contract in a very layman, it's a self-executing program which automates the action required in an agreement or a contract. So what it means in general, any piece of code is something which is made up of if and there's a statement. Any piece of code is something which takes certain input, depending upon certain event, goes into conditional statements and execute actions written in that particular piece of code. So that is what it is writing about. The tenant, since whatever happens gets recorded on blockchain, so it means transaction becomes trackable, shared across the world because it becomes irreversible because these transactions are again recorded in chronologically in a cryptographic hash fashion, and the ledger is appended. This also permits trusted transaction in agreement to be carried among disparate and anonymous parties without need of central authority. So let's say if there are two parties, I and somebody else, and wants to enter into a contract. Currently, when you write a contract, it is always open to how a third party is reading that particular English statement, how that third party is reading that particular contract, and it becomes open to interpretations. But a piece of program or a piece of code is never open to interpretation. It always has a deterministic output for a same type of input under same condition, under same state, the output will always be same whenever that particular piece of code is executed. So it means when a contract is coded in form of a smart contract, it actually brings in complete objectivity, what wants to be attained, what needs to be done. That is why a centralized authority intervention is not required. As it is not depending upon interpretation, it is not something which depends upon perception. It is kind of a law or kind of a statement which are mathematical in nature, which will produce same output under same events, under same condition, under same. Also, a smart contract, as I talked about, gave blockchain element of execution. It also provided them with a functionality of data store also. So by default, they can add mappers into it, they can store data into it. At the same time, people can interact with those smart contracts and retrieve those information, get those information. This particular slide actually, so any question at this particular point of time? I will again take a pause of 2 minutes. Any question regarding block formation, regarding smart contract in general? Feel free to type in, feel free to ask to me. Okay, so this particular slide in totality explains everything what we have been talking about. So how the blockchain formation happens, how the transactions are broadcasted, validated, added, and recorded. So let's assume a blockchain network is running, which means it will have, so when you consider a node, it is always, a network is always made up of computer system, which we call as node, which are interconnected, which are talking to each other, which are able to broadcast information to each other, and they form of a part of a network. The very unique thing about these computer systems is they all are running a same piece of code which adhere to same protocol. That will depend upon which blockchain technology is getting used. In case that particular network is Bitcoin, it means all these computer nodes should be running a Bitcoin client with them. That client can interact with a third-party system. That client can interact with a programmer. That client can interact with a developer. At the same time, that client is also interacting with other client, disseminating information, receiving information, storing information, and validating information. So now somebody comes and somebody wants to put a transaction. He will interact with one of these particular node. He will put his request, he will put his transaction in one of these particular node. All these nodes then via P2P protocol communicate what that particular transaction has been requested to all the node. Due to network effect, it will reach every node. Each node will independently then validate that particular transaction request, what has been requested, then what has been invoked. In case a value transfer has been invoked, each of those nodes will go and see whether that value transfer is correct or not, what the particular person or entity is trying to transfer, does he have that value? Those checks or balances are applied. In case he initiates a smart contract action, then events are looked in, what events has been invoked, what conditions are there. Each of these nodes run those piece of smart contract independently on their own system. They will produce an output. Each of these will produce an output, record an output, store it locally. Each of these nodes, after doing this, will transmit, will disseminate that particular information to all the nodes, telling that this is what we have received, this is what our action, this is what is our result. In certain blockchain technology or in every blockchain technology, when all these things happens, there is somebody who is going to publish or is going to have a final say around what needs to be recorded into the ledger. Depending upon what kind of protocol blockchain technology is running. So there are, in certain systems, they are called miners. In certain systems, they are called validator. These people who put in these record are rewarded for that particular thing. In certain systems, they are required to stake amount to gain that particular access. In certain blockchain system, they are required to solve a particular piece of puzzle in order to have the authority to put that particular information into their node. They are called miners. So when that particular action has happened, everybody is going to say, okay, this particular information which has been published is correct. We can record it in our local copy, and that's where the transaction gets finalized and transaction is finished. Also, one thing which I missed. So all these transactions can be individual but when these are published, they are always published in form of block. So a new block will be formed, and that particular block will be published in all the nodes. Now, these particular blockchain technologies, depending upon the use cases, depending upon how system want to use it, can have various type of blockchain. And it totally depends upon all the computer system which are connected in the network, whether they are at the same level or they are at a different level. Are blockchain network open that anybody can become a node, or they are closed? So depending upon those permutation and combination, at a high level, blockchain types are divided into permissionless and permission. Permissionless, what it means that you do not require any permission. If you have a computer system, if you have a server, or you have a compute machine, you download that blockchain technology client, you run, you become a node. Those type of system are called public blockchain system. These are mainly cryptocurrencies which you see around the world, which can be Bitcoin, which can be Ethereum, which can be Cardano, Polkadot, Polygon, or Matic. Permission type of blockchain network in which but I as an individual do not have an access where if I have a compute, I can become a node. I may not even have an authority to download that particular binary. In case I have an authority to download that particular binary, my node will not connect to the other nodes in that particular network because of firewall rules, because of networking rules, or any kind of such. So in this particular permission world, there are mainly two categories depending upon how these authority works. One is called private. It means there is a single authority who only allows people to enter and who only allows people to exit. Then there are consortium. In consortium, what means there are group of authorities, there are group of companies who have come together. They have formed a common consensus that we want to build one single network in which we all will be a party, in which we all will be recording transactions, putting in transactions. So such kind of blockchain in permission space are called consortium blockchain. Then there is an overlap around a permissionless world and permission world. So as these all innovations across types, categories were happening, people wanted to utilize good of both the world. So there are a lot of aspects good which any public blockchain is total transparent, right? It has total trust. Why a private blockchain is required? Because or a permission blockchain is required because a lot of companies want to use these beautiful feature of blockchain, but they have certain sensitive information, they have certain sensitive data. They do not want to divulge to the outside world. They want to keep it within themselves, or they want to keep it within a group of people. So such kind of things, consortium. Now, if there are certain type of use cases which requires them to have certain data to be transparently available, at the same time, certain data to be available only to private or consortium, such type of blockchain types are called hybrid types, in which it is controlled with one authority, but with a permissionless process. Okay, so that's what, and today's general introduction to blockchain. So before jumping on the problem statement and the core thing, any question at this particular point of time? So the very problem statement which we are dealing with today, how to stop mobile theft or IoT theft, which is becoming very much rampant. And that theft is not only causing financial loss of device or loss of device in financial term. These devices also contain a lot of personal information. These devices also contain a lot of financially sensitive information, right? So that is the overall arcing problem state. There are a lot of solutions, or there are a lot of ways different countries are trying to solve it. There are different ways of approaching the solution to it, but none of the solution up till now in totality solves the problem. It 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 has a lot of issues around which we'll talk today. So one of the very important current method of stopping mobile theft prevention is to blacklist IMEI number, right? So IMEI number is something which is associated with the mobile devices. It is associated with the SIM card slot, which you use, which you enter, in which you enter your SIM. And currently there is so every country has this central equipment identity register. There are certain steps also in order to implement this particular central equipment identity register in a global forum, which has an information around which place where this particular or which particular network provider, which particular mobile number is using that particular IMEI slot. So CIS system aims to block use of lost and stolen device on mobile network, rendering them useless for making calls or accessing mobile data. So what happens currently in general, if I will talk more, which will become more relevant as I see majority of people are here in India. So what process here in India is, there is a website which is known as cir.gov.in. So firstly, if you have lost your mobile device, you need to file an FIR. You need to take that particular copy of a FIR, visit that particular website, provide the FIR copy, provide those information, put in the details. Now, when that particular details are put it, what happens is that particular information is disseminated to all the network providers that this particular IMEI number mobile has been stolen. So if somebody is connecting to their network via this particular IMEI device, kindly block it. Do not allow call to go through it. Now, in current system, the process of doing an FIR, process of putting this particular entry into a database, then other party reading that particular database from their system, pulling out that data, putting into their system is a very lengthy process, involves a lot of time delay. A lot of time, these time mobile devices are not only stolen for financial gain, they may be also stolen for doing certain activity which is criminally illegal. And since that is a stolen device, they can get away with it, right? So these delay actually brings in a lot of problem. So, and this is the best possible method currently which is available. IMEI blacklisting, it acts at a network level. It doesn't depend upon what type of mobile phone you have, what type of operating system it is running, whether it's iOS, whether it's Android, it doesn't matter. It doesn't matter whether location services are on. It doesn't matter whether mobile data internet connection is on or not. What it matters is that particular mobile needs to connect to the network in order to conduct activity or in order to make a call. So you block it on the network to disallow that particular mobile to connect to the network. So this is currently the best possible method which is out there in public. There are other methods which I called as app-based method. App-based or OS-based method. This at times depend upon what type of operating system you are running, what type of application you are running. Certain mobile manufacturers provide them these things as inbuilt. Other time, either you will be required to install them on your own from either Play Store or another type of store, depending upon what type of operating system you are using. They may be paid in nature. They may require you to share additional information with them. Right? So these type of solution are also available, but these are little bit more customized, little bit have a little bit more entry of barrier, are not present by default. Now, if we talk about challenges, I have already given certain challenges around IMEI block listing, but this particular slide actually defines all those challenges in a bulleted fashion. So network blocking of device does not happen in real time. Very important reason, there are data silos. One of the very important factors which we talked about blockchain advantages, removing of data silos. What kind of data silos are there? Data silos are present in form of, there is one database which is for CIER. Then there are databases with different ISP provider, right? So, and these all databases are not communicating with each other in real time because lack of trust is there. Other important aspect is problem. You as a user can have multiple devices associated to you. How to make sure or how to map user ownership when these devices are also sold in secondary market. You are not buying these devices directly from the manufacturer themselves. There is a chain of event which happens. Firstly, mobile manufacturer buys equipment from OEM, assembles it, builds a mobile for you, deliver it to a distributor. From distributor, it goes to a retailer. Retailer then sell it to you. There are a lot of chaining of events which happens in between. Ownership gets transferred from the mobile manufacturer or device manufacturer to distributor to retailer, then the end user. Now you as an end user, again, you can sell this particular thing in a secondary market, or you can give it to be used by somebody else in your family, right? Though you have bought a mobile, but somebody else is using it. So how to make sure that these identity issues are resolved, that these identity issues are properly documented, these identities are properly attributed. Other very important problem is whatever IMEI blocking current system is, it's very centralized in nature. It has a centralized architecture in place. There is a single trust domain, that is CIER. If that is compromised, there is nothing to safeguard. So again, I will take a pause here for 1 minute if anybody has questions around the problem statement and what challenges do we have. So talking about solution, and we are still talking solution in more functional fashion. At the end of the day, when this session is done, what is very much required is for you all to go and explore how these solutions can be mapped to blockchain, how blockchain, which particular blockchain tenant is going to bring in these features in place, how to build this particular solution, in functional as well as in technical form. And in next session, we will dwell deeper. So as related to challenges, we need to solve for device identity. We need to make sure that device is identified uniquely. Real-time dissemination of information is very much required. User identity to be able to authenticate device ownership, that how a user can authenticate that that device belongs to him. And a place to have a multi-stakeholder handling. As I told you, there are a lot of stakeholders are involved. Other very important problem is why this stakeholder problem is something which I missed in previous slide, but let me elaborate now. Now, in MEI block listing, we told, okay, we will block MEI number and it will be blocked. But see, once device has been stolen, it can be dismantled. Each of parts can be taken, and again, a new assembly of mobile can be formed. They can generate a new MEI number. They can take this mobile from geographical location to a different jurisdiction. They can take mobile from India to, let's say, a country in Europe, where their particular CIR will not have their device information, or they can generate a different IMEI number on flight. So it is very problematic actually to plug these holes, how current centralized architecture systems are there. And as there are a lot of these stakeholders are involved, you have different kind of OEM. Somebody is developing battery, somebody is developing sensor, somebody is developing camera of mobile. These days, camera itself in mobile is very heavy, very costly. Somebody is developing microprocessor, somebody is developing other kind of sensors. And these are different people, these are different companies. There are different network providers. There is Vodafone, there is Airtel, there is Jio, right? How to build a system which is robust, which has distribution in place, which does not have a single domain centralized architecture problem, which is decentralized in nature, solves the problem around latency, that as soon as the device is stolen, at the same moment, at the same time, without much delay can be blocked. Device identities are uniquely identified. Those can be translated into real-time actionable law enforcement agency to take action, where you can easily identify your ownership, as there can be secondary market sales. There are a lot of aspects. Our invoice here in India may not be identified somewhere else, right? How anybody can pick up an invoice in Europe claiming that, okay, it was owned by him, he bought it, right? So there are a lot of issues around it in current solution, or in how current solution are there. So our new solution need to solve all these problems. And if you look into all these problems, there are 4 pillars which we need to consider. One is trust and transparency, other is decentralization, identity, and latency. If you are able to build solution which solve for these 4 core pillars, or have certain technology tenants which have these 4 core pillars, solution will be more robust. And whatever we have learned about blockchain till now, these all 4 pillars have the underpinning in blockchain, have the underpinning in blockchain solutions. So that is all for today's session. What I expect from you guys is to go and brainstorm around the solution. We will share these slides with you. Try to explore more around how different countries, different area people are solving this particular problem. Lacunas are the same, which I have told everywhere. How you are going to integrate blockchain solution into current system, involving law enforcement, involving government, involving other agencies which are required to take action. Because just an independent system won't work. It has angle of criminality. Law enforcement is going to come by default, right? So any question related to this session apart from what I have in the chat, please. Now the question is open for any kind of question, whatever you want to ask, whatever has happened throughout the sessions. I will take it up. Yes, so I told Anil, right? So there are current solutions which are in place where you are required to put an FIR, you are required to put that particular entry into CIR registry. Let me send you the link of that particular website so that you can go and read more about it. What solution I am talking about is more India centric, but throughout the world, similar kind of system exists, whether it's offline or online. Regarding your first question around what is layer 1 protocol blockchain. So general, when blockchain concept started, it was only layer 1. So any blockchain, when looked in individuality, in looked in isolation, any network any base network is always layer 1. So what tenants should have, it should be a blockchain, ledger should be immutable, there should be a reward mechanism, incentive mechanism, so that people who are participating can participate. They are incentivized to act honestly. But all these systems started to have issues around scalability, issues around how much transaction can be put in, transaction throughput, issues around transaction cost. So for example, a transaction in Ethereum requires a minimum 12 to 15 seconds to finalize or materialize. I'm not saying finalize, to materialize. In Bitcoin, it is around 10 minutes. Since these all transactions are clubbed and bunched and put into a block, there is a limit or ceiling or cap on, it can be on number of transactions, it can be on block size. So it means at a time, only given number of transactions can be put into the system. So in order to solve these particular problems, so there is a famous saying in blockchain world, which is known as blockchain trilemma. If you go to my LinkedIn profile, I have already written a few articles around blockchain trilemma, and those trilemma solutions are current layer, other layer blockchain which are there. So before that particular aspect, there was no layer 2 or layer 3 blockchain aspect. So since these problems are there, people started building one more layer of blockchain, which is called layer 2. So the base layer blockchain by default called name layer 1 blockchain. So any cryptocurrencies like Ethereum, Bitcoin, these are considered as layer 1 blockchain. Cryptocurrencies, blockchain network like Polygon are considered layer 2 because by default, they lack certain element of decentralization. So what they do, they allow all the transaction to be put into their system. At regular interval, they create certain hashes, they create certain links and commit a data into a layer 1 blockchain as a proof. So that is why they say that they are layer 2, because they are not fully decentralized, but they use layer 1 blockchain to achieve more better aspect of decentralization. Anil, there is no full-scale blockchain solution which are present or anybody is using. People would have done certain POCs around it, but throughout the world, nobody has a running blockchain-based solution as well. Okay, thanks, guys. If nobody has any question, we will close for the today. And just putting in my LinkedIn profile link, you can go and read the articles around blockchain trilemma, which will give you a little bit more better understanding around what I'm talking. Avni, can we also float to make sure that when we have floated the slide in the next session, we do expect people to come up with certain written solution, and we will allocate certain amount of time for them to speak around their solution, what they think.
Sure. We'll do that for the next.
Okay, I want so that the next session is a little bit more interactive and people have also done their part of homework. Okay, thanks everyone. Thanks for joining in. Have a great day. Bye.